Our neighbor in space, the planet Mars, has been the subject of humanity's fascination for many years. In our solar system, this red planet is the fourth closest one to the Sun and our planet's second closest neighbor after the terrestrial planet Venus. But aside from its proximity to our own planet and its beautiful reddish appearance, our interest in unraveling the mysteries of Mars really stems from the similarities it shares with Earth and the potential for its habitability. It is believed by many scientists that this terrestrial planet was once more habitable than it is today. Some have speculated that there may have been life on Mars billions of years ago, while others are really not ruling out the likelihood that life may still exist there right now. And in recent years, experts in astrobiology, equipped with their ever-increasing knowledge about the planet and the advanced technology to study it, have become more determined than ever to find proof of life on Mars, or at the very least, some form of verification that it was once inhabited. Of course, there are various environmental factors being considered to predict the habitability of our neighbor planet, but scientists have placed a particularly heavy emphasis in finding one particular evidence: the presence of liquid water. Now, if you don't know, the surface of Mars currently has an extremely cold climate and is deemed to be way too dry for any presence of life to be possible. However, experts do believe that there is enough evidence to suggest that the red planet was once home to several bodies of water, like oceans and lakes. As for how Mars virtually lost all its water billions of years ago, the exact answer remains a mystery, but it is speculated by some that a cataclysmic event may have been the root cause of it all. The planet is assumed to have lost its magnetic field around 3.8 billion years ago, and extreme solar radiation resulted in the evaporation of liquid water in the Martian atmosphere and the escape of water's hydrogen molecules into space. The theory that Mars may have been very similar to Earth due to the supposed presence of liquid water on the planet in its distant past does give rise to speculations that life might have also evolved on our neighbor planet during this ancient period. And though its surface may be completely devoid of liquid water today, this does not mean that Mars doesn't have any water at all. Now, aside from the abundant volume of water ice found in its two polar ice caps, scientists also believe that liquid water is still present on Mars. It's just that it's really deep underground. Now, aquifers are permeable rocks found underground that bears groundwater. On Earth, water stored underground manages to find its way to the surface through natural springs or by pumping. And so in the case of Mars, scientists believe that should life still exist there today, the chance to unravel this mystery lies in finding where these hidden reservoirs are located now. Of course, all this talk of searching for life and water on the planet Mars has gone on for many years, but how are we actually faring in finding evidence that supports such theories? Have we compiled enough data to state for a fact that there is an ancient ocean on Mars? Are we any closer to finding the underground water supply? So to answer these questions, let's talk about some of the Mars-related studies published in recent years. In 2002, the European Space Agency revealed that their spacecraft, which orbited Mars called Mars Express, detected sedimentary deposits on the planet's northern plains. To the European researchers, the fact that the Mars Express's radar detected low-density materials and ice in this region is indicative that this area may have once been an ocean. The agency's findings using subsurface radar are really not surprising, but they have added to the existing data gathered from images, atmospheric measurements, and mineralogical study of the planet, which already previously pinpointed the northern plains to be the site of ancient Martian shorelines. Within that same year, planetary scientist Francis McCubbin of the University of New Mexico in Albuquerque and his colleagues published a study on Martian meteorites containing hydrated minerals, which allowed them to estimate how much water exists today in the Martian mantle. The authors of the study determined that Mars does have enough water in its mantle to submerge the planet for as deep as 200 to 1,000 meters. This means that the planet is currently shrouding around 70 to 300 parts per million of liquid water somewhere beneath its surface. Then there's also the study published by the international journal Icarus in 2014, which revealed that a team of geologists found evidence of a vast ancient underground ocean located beneath the surface of Ram Chaos, one of the impact craters on Mars. Basically, around 2.5 billion years ago, around 93,000 cubic kilometers of water supposedly broke through and flooded the surface after the lake ice, which was concealed underground, melted and its ceiling suddenly collapsed. And here's an idea of how much water actually reached the Martian surface at the time. They say it is equivalent to around 80% of the free-flowing fresh water that exists on our own planet today. Moving on to 2015, where researchers at the NASA Goddard Space Flight Center in Maryland developed infrared maps of water isotopes on Mars, which showed the distribution of atmospheric water on the planet, basically H2O, in its deoderated form HDO. In doing so, they were able to estimate how much liquid water Mars used to have. So according to their findings, Mars may have once had enough water to cover up 20% or about a fifth of the planet's more than 4 billion years ago. The study also suggests that the planet could still contain some subterranean water reservoirs and that the key to finding them lies in refining the infrared maps they had developed. That same year, another study revealed that NASA's Curiosity rover, which landed on Mars's Gale crater back in 2012, managed to measure estimates of the concentration of subterranean water on the planet. The new measurements suggested that the soil in Mars is moist with liquid brine. The presence of this liquid brine is supposedly caused by the perchlorate salts found in the soil, as it is known to reduce the freezing point of water. The salt is the one responsible for absorbing the water vapor from the atmosphere, which then precipitated under the surface. Researchers consider this find as an indirect evidence of transient liquid water on the planet, though they insist that the presence of liquid brine is not enough to deem that Mars is equipped to support terrestrial organisms. So that brings us to 2016, where an underground layer of water ice was also detected within the planet's Utopia Planitia region. Researchers used the Mars Reconnaissance Orbiter again, particularly its ground-penetrating shallow radar instrument, and after they analyzed the data provided by the high-powered radar, they discovered a massive deposit of water ice in the area that is much bigger than Mexico. This subterranean ice deposit runs really deep, between an estimated thickness of 260 feet to around 560 feet. So what this tells us is that we're pretty sure that liquid water once filled a sizable portion of Mars and may still be lurking beneath its surface somewhere. And usually when there's water, there's life. That means that, yep, there's Martians just inside the planet somewhere. And although more likely than not, they're going to be microorganisms, but who knows, maybe they're all just moved underground and just living very comfortably inside the planet. Or maybe when Mars ran out of water, they all moved here and we were the original Martians. All right guys, thank you all so much for watching this video. See you later.